recording. Yay. Okay. 2.1, talk to me. After what did you say?
27.
27. Any others? Even?
49 and 52.
52. Okay. Really?
Oh, one, was there 52?
25. Okay. Any others besides that? Yeah.
Was there 52 on the homework? I saw.
All right. Was there 52 on the homework?
I think so. Were you looking at like the old sheet that had like all
Yeah.
one for one?
Yeah, I didn't change. I don't think I changed to 2.1, did I? Yeah.
Well, you did, but it was like, yeah.
And then I changed it back. So you can talk to me here. Or we can handle it on Friday as well. That's fine too. Whichever one.
Oh, 57.
57. Okay, no problem. Okay, any others? Going once, going twice. Let's do 25 and let's move on. 25. It says, sketch the graph of the quadratic function without using the graphing utility. Identify the vertices, axis symmetry, and the x-intercept. So this is dealing with x squared, right? We should know that x squared does this. It's just a parabola, comes down, comes up, or it could be that it's going up and then down. So we're kind of looking for that piece right there. So let's go with 25. We have ourselves a 4x squared minus 4x plus 21. Cool. All right. So one thing we can do. Notice that it is not in this little form that we like it to be in, right? So we don't know h and k right away. We're good there? I wish it was in this form, then we'd be graphing it right away, which is like all the other ones. 25 changes into trinomial form. How do we do this one? Rhetorical question, don't answer. Okay, so what we do is do this here. We can either do it the long way. The long way was this right here. What we do is we separate. So don't copy me because this is the long way. We'll do the short way in just a second here. Remember this little piece right here. Remember that? Remember doing that? You guys remember pulling out the 4 and then doing that. And then taking that little -1 divided by 2, which would make a -1/2. And then squaring it, which would make a positive 1/4. Is that true? And then what do we do to compensate over here? What do we have to subtract out? 1. We got to subtract out a 1 because we're technically multiplying it by 4, this whole entire parenthesis. So 4 times 1/4 is 1. So we compensate by subtracting 1. So I think we're ready. 4 over here. This will be x minus 1/2. And you guys ask me questions if you have them. 21 minus 1 is a 20. Are we good there? And so now I know my vertex is, I'll put V for vertex. Vertex is at positive 1/2, comma 20. Are we good there? Thank you so much, Jenna. Okay, are we good there with the vertex? Is that what Bob said in the back of the book? Cool. All right, and graphing this guy would be like 1/2 here, and then we're all the way up to 20. So at this point, we're just going to make a graph like this. As long as it's kind of in the same region that it needs to be, it's very, very slope, right? Very steep. There it is. So there's that one. Okay, good. There were 25.
For 13 through 27, we're supposed to find the vertexes.
Vertex, says find the vertex, and then axis of symmetry. I think I forgot. Axis of symmetry is this little symmetry right here, right? It's the x coordinate that comes down. So let's do this here real quick here, so we can do it all. Yeah.
So how do you get the -1 outside the?
Since we added 1/4 inside the parenthesis, we always think about whether we have a multiplier here. So technically, this was a 4x squared. This was a -4x from top. So this would have been a +1 right here sitting. So we compensate that one right there. Yeah.
did not see that.
Yeah, that's fine, yeah. Yeah, eventually, if you get to the graph. Like, can I do it the short way? This one was the last problem we did right before we left. When we were doing this section here, so that was the long way, let's go short way, 4x squared minus 4x plus 21. So remember how we got to this point? I said we didn't have enough time to do the formula for it here, but here it is. That little guy is going to give us the exact same x value that we just did earlier. So let's plug it in. This guy's the a value, that's the b value, and that's the c value. So if we put negative of a -4 over 2 times, did I do it right? Yeah, I think I did. Let's see, that becomes a +4 on top, 8 on the bottom, and I get myself, voila, which is the exact same answer that I got right here for the vertex. Are we good? First way, second way, which one do you guys want to do? Yeah.
So when you use the short way and find the x value of the vertex, you have to plug it in to find the y value.
Perfect. So now the question is, I have my x value. This is a function. And so we should talk about this here, this AOS. It's called the axis of symmetry. All right, so axis of symmetry, whenever you have a parabola, any kind of parabola, axis of symmetry is the vertical line that's going to cut this guy exactly in half. That's what you're looking for. And vertical lines are always in terms of x. We're good? And the axis of symmetry is always your vertex, or the x coordinate of the vertex. It's this guy right here. All right, except it's not a coordinate, it's a vertical line. Okay. So in this case, we say, so what's my axis of symmetry here? My axis of symmetry is x is equal to 1/2. Good there. We also have one more piece of information. We know that the x coordinate is 1/2. One slide. Okay, and so someone said it here. So if I know the x coordinate, can I plug in to get the y coordinate? Absolutely. Let's do that here. So I'm going to put f of 1/2 inside here, makes 4 to the 1/2 squared minus 4 to the 1/2 plus 21. Let's see if we can do this quickly here. That's going to be 1/4. 1/4 times 1, that's just 1. Plus or minus 2 plus 21, is that right? And so this one, however you want to do it, the way I normally do these problems here, if I have see all, I'm going to put all the positive numbers together. So I see a +1, a +21, that's 22. Put all the minus numbers together and get 20. Voila. Everybody okay there? Show of hands, here we go. How many like the first way? First way was awesome. First way was long and tedious, and we had to move things around. It was cool. No, I like the second way. Second way is cool. I got the formula, plug it in, and we're good. Okay.
Good answer. Oh.
Yeah. Somehow I was expecting that answer. Okay, we're good there with 25. Now let's move a little faster with 27. So 27 says I have 1/4 x squared. So notice I'm not being very precise with my graphs. We'll get to more precision as we go through the rest of the chapter. Then we'll actually put in x-intercepts. We'll put in the whole thing. We'll have a nice graph of these guys. Okay, so let's jam the fast way here. So since you guys like that way, negative b over 2a. -2 over 2 times 1/4. Oh boy, fraction and a fraction. So 2 there. 2 times the half, or so 2 times 1/4. Yeah, that's gonna be 2/4, and eventually will be 1/2. That's cool. And let me show all the work here. So then I'm gonna make this into 2 different fractions. I'm going to make this guy to be the same. So no changes here. Change to multiply. And we take the reciprocal of this guy. And the answer is 4 is good. So AOS, my axis of symmetry, is x is equal to 4. My x coordinate for my vertex is 4. And now let me just go and jump in and figure out my y coordinate for my vertex. 1/4 4 squared minus 2 times 4 minus 12. Boom, boom. Okay, what do we got here? 4 minus 8 minus 12. Anybody with an answer?
-16.
16. And then does Bob agree with you guys? Maybe. Yeah, okay, Sterling says yes. And Lindsay says, I hope so. Okay, so as far as the graph is concerned, as far as like what we need to do in the graph here, let's do this here. You do have to do the vertex, obviously, right? Second of all, you have to know whether it's going up or down. You guys talk to me, up or down? Up. And then the next piece is that little extra little 1/4. So what I expect on the graph, in a sense, would be something like this. Just give me 3 points or so. So 4 would be about right here. So maybe we need to scale it as well here. That's 4 here. And this is, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, can't do it that way. Anybody have an idea how we should do this here?
Just make each change it by 3.
Thank you. And don't erase the. So 3, 6, is that okay? Or maybe make it by 4. 4 would help. So 2, 4. No, 4, 8. Thank you. Thank you, Calvin. Help me with multiples of 4. Math teacher forgot. So this is by 1s and this is by 4s. We're good. So I got myself 1. So 4, 16, 1, 2, 3, 4. Right there. There's my. I know this is going up. The only point that we probably need is if I go out to the right 1 unit. So like this right here. Do you guys remember this one here? If I go out to the side 1 unit, I square the 1 and then multiply times a. What's my a value here? 1/4 over here, right? 1/4. So this would be 1/4. So I'm going to go 4th up. And my scale is in terms of 4, right? Because this is going to be super wide, right? So if I go out to 5, this guy's just barely above like that. And this one's also going to be like this. So this would be pretty wide. It was a -16? That's cool. Oh, that's cool. That teacher did everything wrong. Thanks for telling me now, at least.
Yeah.
Then 5. No, we're good. Let's go here. I'd rather you guys tell me. Okay, now it's going up, so that's cool. So now we're gonna go, it's gonna be pretty wide, isn't it? Because you're gonna go, so this is negative, so this is 4, -16. We're gonna go out 1 unit to the right, and we're going to square the 1 unit because we're going out to the right, but we multiply by 1/4, so therefore we're just gonna go up 1/4. So that's just like barely, right? Because this goes in terms of 4 scales, right? That's just gonna be barely anything up. This one's gonna also be here. You know, the only other dot that you can put on the homework, which is an easy dot to put in, is the y-intercept. Let's do this here. What's my y-intercept here? If I plug at x equals 0, -12. Absolutely. This little guy's my y-intercept. Notice how easy it is to figure that one out. So at this point, maybe like just put this dot in, because we're just, eventually we want to get to nice graph of this stuff. We're good. So this guy is super wide like that. It comes in like this. And then it's going to go out approximately the same steepness. Okay. We should have to see something like that. Good. Yeah, go ahead, go ahead.
Do you have to do like the axes in different intervals? Because you have the y-axis like 104, and then you have the x-axis 104.
You don't have to. I did it so I can see it on my screen here.
Um,
But if you have enough piece of paper that you want to go all the way down to 16, no problem. Okay. Da-da-da, da-da-da. 25, 27 is good. Okay, 49 and 57. 49. Let's see what this guy says. All right, we're going backwards here. So now can you give me the equation of a circle, of a parabola that goes through? And you guys talk to me, is it negative 1/4? Or don't talk to me, okay? So vertex is right here. Oh, 3/2. Thank you. 3/2. Okay. So how do you go backwards? Well, the go backwards part, the easiest way to do it was to plug in back into this little equation right here. Since this is our graph equation, we can plug stuff back into here super fast because H and K are the vertex. So voila. So if I plug in, I don't know what A is, but I know that if I plug in H, anybody tell me what is that gonna be? X plus 1/4 or minus 1/4? It'll be a plus because it's almost like subtracting a negative 1/4. So that comes in like that. It's a squared term, and we got ourselves a plus 3/2. I think this one was here because of fractions. Is that right? Okay, so we have our vertex. We got all this stuff in. Notice we're just missing A. If I just knew what A was, I would have this as my equation here. So that guy steps in. So my input is going to be -2. My output 0. So if you want to kind of see what this means, X is what we put in for X. And that's what we're going to put in for f of X with it because it's the same thing as X and Y. So 0 goes here. A, we don't know, but we're going to find out in just a bit here. So -2 plus 1/4 to the second power plus 3/2 will give us what we need. All right, and then some work ahead of us here. So I think I'm going to have to get common denominators here. So I'm thinking 4, 2, I'm thinking 4 over here. What's the number on top here, anybody? Perfecto. Thanks, guys. Okay, -8 plus 1 will make -7. So I'm getting there. I'm getting closer. Well, you know what? Let me see if I can do this fun little trick here. That's home. No, can't do it. Can I do it? Let's see. Oh, yeah. Copy. Love PowerPoint. Okay. We got ourselves a -7/4, someone said. Keep on going. And then we have ourselves 49/16. Is that right? After the square takes place. Whew, this is getting longer and longer. And then we have ourselves 49. And you guys tell me if I'm making any mistakes here. 16 plus 3/2. Oh boy. Now you can go one of two directions here. But let's do this. I'm going to get common denominators here, stuff 16, because that's probably maybe easier to do. So tell me what is on top of the second 16 over here? 24 is good. Oh, even better yet. Man, this is awesome. 1 second, hopefully. Nope. I else here. Cool. Let's go multiply by 16. If you multiply 16, isn't that just gonna go away anyways? And then let's see, move the 24 over. Man, divide by 49. Is everybody finally okay with a negative 24 over 49? And is that what Bob agrees with us or no? Lindsay's answer is
Bob better, or
maybe.
Bob might not.
No,
Second?
negative
It was a
49.
lot of answer, it was a big answer with a lot of fractions.
Oh,
It
yeah.
was 49 over negative.
So,
Yes, that was right.
Yeah, negative 24 over 9.
Yeah, you just have to plug it in. You have to
Okay.
kind of mid distance.
So, now plug that in for A and you got your answer.
I have back.
Oh, reversal.
49 is a negative 24.
Okay. We have,
Maybe I just rolled.
let me see if I can jump to it here.
But what I did was divide 49 over 16 by 24 over 16.
You went the other way, you went negative 49 to that side?
Um,
Eli, what did you do?
Well, what I did was I plugged in 182 for X. I multiplied that up by 16. I converted 3 over 2, and if I wanted to get 3 over or to 20 over 6, then negative 24. 24 over 6. And then if I wanted to get 0, then I have to figure out or then I divide by 49 over 16 by 24 over 16 to get what the other.
Yeah, so you're here though, right? You're over here?
Yes. And then I divided 49 over 16 by 22.
Okay, gotcha. Okay, so right here, you can't do it yet here. You'd have to move the 24/16 to this side first.
You have to flip it.
And then you can multiply it. Then you can flip it. So we can do that real
I mean,
quickly here.
divide it because then I get 8 out of that.
Ah, okay, so let's
Or
see.
lose.
Yeah, let's do it, because just so you have that right there, is that what you have?
Yeah, yes.
Okay, so in order to now do this, you divided by this whole thing, is that what you did? Okay, cool. So let's do this way here. So Eli divided by 49 over 16 here. We're gonna go over here, divide this guy by 49 over 16. If you do that, eventually this guy would have to be negative 24 over 16 multiplied by, and this guy will have to be the reciprocal right here. Now notice the little 16s will cancel. So you're still gonna wind up with a 24 on top and the 4 on the bottom.
Almost just right there.
Yeah, I didn't think you just didn't flip that piece, or you flipped the other one instead. Okay, so finish it up here. I got myself, my answer is negative 24 over 49. X plus 1/4. You guys help me out here. Plus 3/2.
Yes.
Sweet. Okay. And then last one, 4 to 57.
Can you go back?
Oh yeah, sure. Ding, ding. So this is for 2.1, right? 2.1. So for these right here, 57, 61, 63, I wanted you guys to use a graphing utility, your calculator. We're good. Just to graph these. And you guys talked to me. That's kind of where we finished off with 2.1, right? So because we have less days this semester, what we'll do is like when we finish 2.3, I'll kind of cut a little bit of the homework off. We're good. I'm gonna see, just because I can't cover every single thing. Plus we could fill it in a little later. We're good. So I'll be editing the homework sometimes if I need to. Okay. So did you guys do 57 and on?
Yes.
Okay. Was it pretty easy to do on the calculator? Desmos. Okay, yeah. Some people use Desmos, some people use calculator. Go for it. As long as you kind of just graphed it, and you should It says look at the x-intercepts. Again, don't worry about that for now. I just want you guys to be able to, can you guys graph this on a graphing calculator? That's what I needed to know. And transfer it over.
57 and 61.
Yeah, 57, 61.
What exactly did it compare to X?
It wanted you guys to solve for the x-axis and then also look at the intercept, but we'll integrate that a little bit later when we actually start solving for it.
Okay, I just put down shift to compare to.
Ah, gotcha. So on the graphing calculator, if you use decimals, that's fine too. Just whichever you guys want to use here. But I'm gonna go real quickly here. I just want you guys to be able to comfortably graph these guys. So for 47, this is keeping this problem, isn't it? Right? We'll finish out the problem. He won't even know it. Ah, shucks, he's back. Okay, so in order to graph this on the graphing utility, we're gonna have to go to y equals. The screen went crazy. Oh, not that completely. All right, Keith, it just doesn't like your problem. That's what it is. Screen difficulties here. That is so weird. Okay, let me do this here. Let me get rid of that. I wonder if it's gonna come back. Okay, let's try this again. Okay, let's see if calculator comes up.
Oh, weird. A calculator and
Let's
When
see
you
if
divide
this.
0 by 0.
Okay, if we can stand that just for a second here. So just get comfortable graphing these guys in graphing utility, making a nice graph here. It's going to be x to the second power minus 4x. And click enter. And then what you're going to do is you're going to click the graph button. So Keith, and all I wanted you guys to do is just be able to graph it on the graphing calculator. That's it. And then just copy that graph onto your graph. No need to think about, yeah, no need to do anything yet with the x-intercepts.
I put down the x-intercept.
Yeah, moved over. So it's moved over to the right and then down. Jill?
So you just put the equation that we got with that answer is the y equals.
Absolutely. That's it. That's all. Those should be very simple. No need to do anything with the x-intercepts. Okay. Then sometimes you might have to adjust your graph, maybe. Okay. Do we need to do any others? Going once, going twice.
We did 61.
61.
I put down that it was compressed, but I'm not sure.
Oh yeah, on this one right here. And again, don't need to do anything else besides plug it in here. Click this guy, plug it in 2x to the second power minus 7x minus 30. Okay, this one's gonna be kind of interesting. I bet you it's gonna be a little bit off the graph here. So we'll hit the graph button and we have that. Oh boy. What should we do? We've got to move it down a little bit here. Maybe change our. You definitely have to move down because I don't see even that the minimum value there. So notice we have this little window right over here. It's going from along the horizontal stuff. It's going from -10 to 10. That was okay. It was just the y-intercept was off. So I'm going to make that a little bit bigger. If I scale it out, how about -40 to 40? We're good. I'm going to just, and then make the scale by 10s. Let's see if that will do it.
Whoa.
Okay, that looks a little better. We're good.
So for one.
So then Also, real quick here, notice it crosses at -30 right here. There's your -30 crossing. Okay, 61 good.
Was that, is it compressed?
It is.
But.
It is stretched along the y-axis
By a factor.
by a factor of 2. Yeah.
I had it down, I noticed that would mean.
Yeah, but for these guys, I just want you guys to be able to graph, make the graph nice in your graph, and then make the scale. So in this case, this would still be ones right over here. This would be in terms of what was it in terms of what? Tens right here. Yeah, 10, 20, 30, 40. Do you have a question?
How do you know it's going to?
Oh, sure, yeah. So when you did this little window thing right here, it's this little guy right here. So your Y scale is by 10. I just changed the Y scale for myself. You could have went by 5s as well. That would have been fine. Okay. We're good there. Should we do last one? Just to complete it. Let's do last one, just to complete sake here. So last one is honors question 63. So this one's a negative.
I think 63 was. Because we're 2.1.
Yeah. For this is an honors question for 2.1. Yeah. He wants to do math too. All right, 63. Real quick here, it says -1/2. Now you can put in -1/2 into here. Just real quick on your calculators. That guy's a subtraction button. That guy's the negation button. So it'd be this one, -1 divided by 2. You can also, if you like, you could just put 0.1, 0.5, right? That's also a half. But we got that. We got x to the second power minus 6x minus 7. We good there? Honor students, there's yours. And then if you want to, you can actually click zoom if you want. Remember, we're scale from -40 to 40, right? We're not scale now. So if you want to, you can click on this something called standard. It'll get you back to -10 to 10. Oh, that's nice. We're good there. That would have been okay. Just to graph that. Okay.
Is that 65?
That's 63.
Okay.
The last one was 2.1, which was an honors question. 2.1.
Oh, okay. You still wanted to do like 65 and 60, like all those ones. That's first.
65, 69, 77, 71.
Did you want us to do the
Yeah,
problems
check.
you assigned first on the worksheet or the ones that you edited?
Sure.
I did the edited portion.
Yeah.
I sent like 4 emails and I just clicked the last.
Okay.
Sorry, Hannah, what did you do again?
Well, you sent out like 4 emails saying
Mhm.
this one's edited, no wait, this one's edited.
Yep.
So I would just
Yeah,
click
so
the
the-
last one and I'm like, okay, this one must be the most recently edited.
The
and
first
then I
one you
just-
had, first one that wasn't edited is saying like not 65, but like 67, 69. I think
It
70.
says-
What is it?
Well, the last one has 65, 69, 77, 71. I did not see.
That's what it was.
Or.
Right, so we guys did do 65 then, right? Yeah. So Keith, yeah, 65 was still up for grabs.
Yeah. I just used the graph and calculator, like 65 and 69.
Okay. I'm gonna leave it there. We good? Good with that? Okay, we got 20 minutes here. Let's jam with 2.3 is what we have on our hands here. This works. Now it should be that way, and this way. All right, probably not gonna get through all of 2.3, but let's get started here. Let's see. Yeah, we can probably do it then. All right. It's
That word.
and that's a little, sorry, that's my little symbol. That's a little symbol. And okay, so 2.3, we're going to learn about polynomial division, or sometimes called long division. I guess I should say that. And synthetic division. You guys remember long division from
Yes,
fourth
do
grade?
I.
Wasn't that
They
fun?
like this.
That was traumatic experience.
Extremely.
Don't do this.
I don't even like.
That's how old it's fine, and then you put one thing on one side.
Okay. That's so funny. Well, let's see. We're gonna review the trauma just for a little bit. Scarlett, go ahead. Oh, cool. Good. Okay. Remind me. Might have to do that as well. All right, let's begin. So yes, we're gonna go back to fourth grade, and we're gonna do one small trauma experience here, if need be. I need to figure out how to divide 5 into 483. Oh, that is so cool, yeah. So,
97.3.
someone's showing off, but that's cool though. That's good. So real quick here, let me go this way.
It's easy. Use the 500 minus 15.
Yeah, but it is pretty easy. My level of math.
Or 10.
Let's jam with it here. So normally we don't put a 0 over here, but we could say 4. 5 doesn't go to 4. 5 goes into 48 9 times. So good. 9 times 5 is 45, and we subtract. Is that right? I remember that. That was the good old days, wasn't it? As well, not the long division part, but like
6 times.
48 minus 45 is a 3, and then what we do is we bring down the 3. Is that right? And then 5 into 33. Thank you. 6 times 5 is 30. We subtract again. We get a 3. And then we have one of two choices. Oh yeah, so we can do decimal point right here. Decimal point 00 if you like. Or we could put R3 for remainder. Remember that?
Yeah.
That was so cool. Get excited about long division.
That makes it way more complicated.
Okay. Okay, well, we're gonna do the third way. The third way was like this.
You need those.
What? The remainder is 3, but we were dividing by 5, so it was 96 and 3/5. That's the answer. We good there.
Remainder.
R3.
Yes.
Okay, good old days. Ready? Just for Keithan, for him to relive the like that. Was it a capital R or lowercase r? Lowercase r. Did it have a little dot next to it or no dot?
It's just R equals.
Oh, r equals.
Yeah.
Like this?
Yeah.
No. Okay, so the sophisticated way was this right here. We're good? Okay, let's talk about it. So we're gonna get super cool in just a second here. So you guys talk to me. Is 96 and 3/5 the same thing as writing this, guys? Is it 90 plus 6 plus 3/5? Is that the same thing?
No. Yeah.
Everybody says yes. Okay, good. Got scared. Is that number the same thing as 90 times 10 plus 6 times 1 plus any remainder stuff? Okay, we're getting somewhere. Okay. So all we're gonna do is we're going to figure out, we're gonna put in variables into here. Good. So your answers are gonna look something like this. Here's your answers. Oh, never mind. I didn't do that here. Okay. Oh, sorry. So never mind what I just said. So is that still true? Does that make sense there? Right, that's still the same numbers, right? Another way to write it was to write it like this, was just 483 is the same thing as, now the only thing is we got to use decimals here. So 3/5, anybody is a decimal? What's 3/5 of the decimal?
0.6.
0.6. Okay, so 483 is equal to 96.6 times your multiplier. We good? Is that still good? That's all true. We good? Okay. So let's jam. So all we're gonna do one small itsy bitsy change. We're gonna put in a variable of x into here.
Small line division.
Totally excited, understand. So our problem looks a little bit like this. So that little 0.6 is 3. Yeah, just so you know. Our problem kind of looks something like this.
Let's say something very simple.
That's it. Besides that, it's all long division.
Besides that, what? Besides that.
Right, there it is.
It's obviously 75.
Obviously. I get off easy.
So let's label this stuff here. So just, oh no, let's go on. It's not 16. Let's just keep on going.
Okay, what is office?
It'd be super simple by the time we're done in 15 minutes. But let's label some identification stuff here. So this little stuff inside is called a dividend. The dividend is the stuff inside the divide symbol. Then the stuff on the outside is called a divisor. And then on top, whatever's left on top, that is called the, thank you. Ooh, you guys know your vocabulary terms. Anything left over is called the remainder. So over here, whatever this is, that will be the remainder. That's the way this works. And Eli, go. Slide. Okay, let me have them fill this out and stuff. Okay, I'll tell you, by the time you do about 3 or 4 of these and you're like, oh yeah, that's easy. Just needs to get there first. Calvin, good.
What's your favorite song?
Whoa.
No, actually, what's your favorite song?
Maybe, I'll think about it by the end of class. Hear about that. We'll see about that too. Okay.
You look like a country man. Y'all look like a son of a-
Interesting. That's so funny. Eli, do you need to go back or no?
Exactly.
I get out of here with that. Get out of here with that.
Okay, we good there? Okay, everything labeled? Let me go back to here. Eli, what you got?
Taylor Swift is.
Yes, he is. What about albums?
That was
Yeah, one of that, whatever.
The best I think one of the.
No, the best one is, that's one is, what happened.
Yeah, wait, you're right.
all right, so let's get going here. Exercise 1. So let's do this here. Use long division or polynomial division. Oh, gotcha. Okay, sorry. We're still writing down the last stuff. Oh, we're still trying to solve it.
What?
What are you trying to solve, Weston?
What's he trying to solve? What?
Yeah.
Okay, so Weston tried to solve it. I guess we'll do it.
Oh.
Water be like when it's still trying to solve and not really.
You and Weston. All right, we're gonna try to get the 3 problems here. Let's see. And so let's go with it here. So long division or polynomial division, we're gonna divide this guy by this. Weston already got started as he tried to do the labeling part. But let's go with it. How do we write it? We write it just like we did before. So x minus 2 is on the outside because that's the divisor. And we're gonna rewrite everything here. Now, the only thing that needs to happen is this. All the degree values have to be represented. So notice the 3 is here, the 2 is here, the 1 is here, and then the constant. And they all have to be in order. We're good from highest to lowest. It always has to go, if it starts at 4, it has to go 4, 3, 2, 1, 0. Tony.
So it seems like, it's like if it goes from like cube to square, you just need to put like 0x. Is that-
Plus 0 and x, whatever. To the power. Okay, so let's begin. Ooh, I'm gonna see if we can get through 3 of them in time remaining. All right, how does this work? Here it is. This little guy here called the leading term. We've been talking about leading terms before, right? That controls everything. We say this x times what would give you 6x cubed. That x times what gives you 6x cubed. 6x squared, right? That's 6x squared. But except the other thing is, remember those lines from 4th grade? This is going to be our x to the 3rd column. This is our x squared column. X column and constant column. So we're going to put, sorry, let me write over again. So we're going to put that little 6x squared right here because it's what the columns of the x squared. So we good? So we're going to keep the columns all in line. So what do? We go 6x squared times x is 6x cubed, and it better be that because that's exactly what we're trying to get in the first place right there. Then we go 6x squared times a -2. Anyone?
Negative.
Negative 12x squared. And then what do we do along division? We should be 6x squared because we're trying to get rid of this little 6 right here. And we subtract right here. So the only thing is subtraction of polynomials kind of gets a little crazy because you got to be subtracting this from this. So it's much easier just to do this. We're ready for the trick. We're gonna change this to a plus sign. And then we're going to change everything here. So I forgot the minus over here. So I got the minus right here. We're good there. And I got this as a plus. So we're good there. A lot easier to do. What? Come on. There. It's doing this funky stuff again here. Okay, let's begin here. So this guy has to cancel out if we did everything correctly, right? Because that's the whole point of doing that. So what is -19 and a +12 going to make? -7x squared, perfecto. And we're going to bring down the next one and everything starts all over again.
Here we go.
So what number times x? And if you want to write it like this, that's fine too. What number times x would give you a -7x squared? Close. -7x, perfect. We're going to put in the column for the x's. -7x times x makes x squared. -7x times the -2, 14x. And what we do again? Cool, yeah, we're going to subtract. But instead of subtracting, we're going to add the opposites. Here's my opposite, here's my opposite, and then here's my opposite. Just a lot easier. If you can do subtraction in your head, that's fine, but it's just so much easier to do addition. What gets canceled out? Bam, that's gone. 16 and a -14 going to make 2x, and we bring down -4. Okay, so now the next question, x times what gives you 2x? It's a +2, huh? Okay, so in this case, don't forget to put the plus to it because we're still adding because that 2 is going to be by itself. So 2 times x is 2x, awesome. 2 times -2 is -4. Ooh, this is kind of interesting. We're going to subtract this stuff. Aren't we actually subtracting the same thing from itself? Notice it's good. It's just 0. If you want to still do all of the work, that's fine, but you're going to put plus sign, minus, change the sign. That gets canceled, but that also gets canceled, and we're done. There it is. It's called long division or polynomial division. And it says, I think it says, write this answer in the back, as your answer. So 6x squared minus 7x plus 12. That's going to be your answer. We're good? Okay. Time for a few more here. Let's go.
You said +12.
Plus 2. Lily, bet. Now we're just barely starting 2.3. So yeah, I'll probably do Wednesday as we get, sorry, yeah, we finish up on Friday. Okay, one more, maybe we can get a. Bless you. B. That's fine, okay. B. Try this one here, a little easier. Yep, it is x squared plus 3x plus 5. Ben, ready, copying? X squared plus 3x plus 5. I'm going to divide that by x plus 1. All right, let you guys try it yourself. Go for it. Rewrite it in terms of the. All right, x plus 1 should be on the outside because that's the divisor. Is that right? And then x squared plus 3x plus 5, that's going to be our dividend. So it goes inside. And let's jam. So x times what gives you x squared? Thank you. X times x is x squared. They better match up or else we did something wrong. X times 1 is x. Long division says we subtract, or better yet, add the opposite again. Ding, 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 ding. And our leading term, again, that little word leading term has to disappear on us, right? Or else we did something wrong. 3x minus x makes 2x. Boom. And we bring down the 5. And we start all over again. Okay, here we good. Am I going too fast? Okay. Yeah, okay. Let me slow down just a bit here. Okay, then the next part is what multiplies x to give you 2x? 2. So we put plus 2.
Whoa.
And we go 2 times x is 2x, and we go 2 times 1 is 2, and then we subtract again or add the opposite. So negative 2x and a negative 2 or minus 2.
Yeah.
Leading term does what? Cancels.
And then we have a remainder.
Remainder now. Hey, the same remainder as we started off with here.
Yeah,
So
divide
3. Let's divide it. Or no, hold on. Let's write it as a fraction, right? So we're going to put plus. 3 goes on top because it's a remainder, and our divisor is not 5 this time. It's x plus 1. Are we good? So there it is.
That makes sense.
There is.
Whoa.
And for the remainder, you do 3 over x plus 1.
Yep.
Mhm. So you would write that as the answer. Okay, so as far as homework is concerned,
If it was a -3, would you do -3 over x plus 1?
we'll get to that one. It's a little bit more complicated, but you can put a plus sign, yeah, and then you can just leave everything inside there. That's probably the easiest way to do it. Okay, class, if you guys want to start on your homework just a little bit here, if you want to, there's only 2, let's see, up through 9, I guess, up through 9. If you want to try 13, you guys can try 13, but up to 9. This is 2.3.
We're not done.
No, not done. We'll finish up on Friday. Just to 9. And if you want to try 13 for the fun of it, go.
Don't your trash it.
No.
Um,